Okay. It's been about 10 minutes. Would anyone, or does anyone want a little more time? Okay. So, did anyone find a link or an example of an OER that is related to your discipline that might be worthwhile to use or to explore more or to edit? Did anyone find anything?
Hi. Yeah, I actually did. And I'm very happy with the things that I saw. I didn't know they existed at all. But
Awesome.
yeah, but my question is, let's say I found 3 books and one simulation that I would like to put together. So if I put that together for my course, I'm worried about attributions and licensing. Is there somebody we can talk to about that in CTRL that would help us finalize things before we put it on our Blackboard site?
Yes, I'm
Okay.
pretty sure. Yeah, I'm sure there is. I can look into it.
Okay.
Yeah, definitely. You can contact me, and I can
Okay.
look into it. And in the end of the slides that you'll be receiving, there's my email address. You can contact me, and we can work together.
Okay. All right. Because basically, I want to put like certain chapters of the 3 textbooks together and put it into one book. That's possible, right? We can do this.
Yeah,
Something
you
like
can
that.
definitely
Okay.
adapt it. You can customize it any way you want. You'll have to look at the licenses to see if they can be
Right.
remixed.
Okay. Okay. All right. Thank you, Erin.
Hey everyone, this is Paula. I actually found something interesting. I'd need to explore it a little bit more, but in Merlot, I found something called the Research Methods Knowledge Base. And it seems to be a very kind of, basic textbook about the fundamentals of social science research, but in kind of an applied type of context, written for an applied researcher to some extent. And I'm thinking I might be able to use that, and then I could then provide my own examples for students of each of the research methods through other articles, et cetera, that I would use that apply it to strategic communication. So yeah, very interested in continuing to explore. For me, I found the Merlot resource kind of giving me more results that I was interested in.
Awesome. That's really good to hear. Very good to know. Anybody else?
Yeah, I also found a useful resource in Merlot. And I kind of got bogged down in learning more about the Creative Commons license, but I learned that I have to give attribution, it's non-commercial, and it's non-derivative. So I can't make adaptations to it, but I can use it for teaching a course on teacher education. So that's useful.
Wonderful.
Yeah, I saw something new in that PhET site. They had some greenhouse effect simulations. But there's definitely a lot of written materials across those sites that look interesting. I've actually, there's these things, the ecological footprint stuff that's Creative Commons license that I've been using periodically over the years. Just good class exercises or lectures, sometimes interactive lectures. So I had no idea they were at AU.
Kathleen, did you have a question? Oh, I think you're muted. There you go.
Sorry. I went on to the MIT course. I teach English at SPECS to international students, and they have an old course from 2002, but they had a lot of really useful sources, for example, teaching argument and some grammar and editing points. And there, they said you can use whatever you want. You can remix it, you can reuse it, you can modify it, and you can share it, just so long as you cite them, as long as you say that it's from OC, what's it called? The OpenCourseWare website. So it's really useful. I may use it this summer.
Yes, and this is all here. I found, I went to different sites and there are materials. I have also, I noticed, same as Kathleen, some of the materials like the MIT are in statistics from 2005.
Mhm.
So it seems to me that these things haven't been updated in terms of the examples, all right? That sometimes we like to give the students that are time relevant. So yeah, that is something to think about. Because I'm sure all the examples will have things that are more in the 2005, 2004, 2003, but for statistics, we need to upgrade with some data that is more current.
Mhm. Right.
But
Right.
definitely, I am very excited with everything that I've seen. I mean, I jump. I went to MIT, to Merlot, to another one. It's just a bit overwhelming now, but very exciting with the possibility.
Good. Great. That's good news.
Mhm.
Stephanie, this is Tara. I would also
Yeah.
just echo that sentiment. I went to the MIT Open Courseware, and although I didn't find any particular readings or resources, there were some syllabi for similar courses. And there was a lot of detail in those syllabus about prompts for response papers, different ways that people have organized the courses that they teach on the same subject that made me think about different ideas that I might want to include as a topic or a question to explore that week. And even some of the readings are ones that I think I would look into further that are available to students maybe through the library or elsewhere. But so some of the syllabi in particular, I think were pretty helpful from just a creative perspective.
Wonderful. Thanks for sharing, Tara. Okay, anybody else?
I found an interesting book. You know, I'm a librarian, and one of the things that we do across disciplines, whether it's first year writing or me working with SOC, is just the concept of information literacy. And I think a lot of students, given where we are kind of generationally, you know, love their smartphones, they love Google, they think because they buy shoes on Amazon in between classes that they are digital experts. And so there is a lot of really kind of reinforcing information literacy, especially as it relates to digital access. And so this was a book that talked about information literacy specifically within the context of journalism. News is very important and complicated thing right now in terms of truth and news and you know, citing sources and whatnot. So I think it's a really interesting book, and I think I will share this with some of my SOC faculty. So it's pretty good.
Thank you for sharing, Derek.
For sure.
Okay, in the interest of time, I think we can move on to the next slide.
Oh, that's me. Hi again, everyone. Thanks for sharing and going through all of the amazing resources Stephanie shared. As you saw, there's so many. There's more than we could ever need to use, but one of the things that Stephanie brought up earlier was the different ways that we can use OER, and so we can apply them to our courses. And so now we're going to talk very briefly about reviewing OER and then moving on to creating your own OER. Eric will talk a little bit about that specifically with statistics and methodology, but a lot of other resources as well for creating your own. So I'm most familiar with OpenStax textbooks. That is the textbook that I use for my psychology course. I teach psychology as a natural science at AU, which is an AU core course. And I'll talk a little bit more about that later on, but that's I use those textbooks a lot for most courses, honestly, that I teach, graduate, undergrad, obviously in the graduate courses, not as much as the undergrad. But just quickly, OpenStax goes through a pretty rigorous review process. Not all OER do go through this, but more and more we're seeing that there's different processes and rubrics that we can use to assess OER before we use them in our classroom, or we can review OER in an official capacity for OpenStax and other places that are creating these OER. So as I said, they undergo a rigorous peer review process, very similar to other types of academic peer review. So if you are publishing a journal article and it gets sent to some reviewers, it's a very similar process, and it goes through at least 4 rounds of reviews is kind of the minimum that they reported. As Stephanie talked about, you can look at the contributors whenever you click on each book, and so you can see the experts that were responsible for creating the OER. And then there's also the rounds of revision. And so on the screen, I have one rubric that's been used to assess OpenStax textbooks specifically. And so you can see it's a really long list. And it doesn't touch on everything though. So again, it's a good process, but just like any peer review process, there's going to be, you'll find some issues probably from time to time. You might find a typo. You might find that things are outdated for sure. So it does go through a rigorous process, but of course, there are definitely going to be issues like any other peer review process. So that's kind of the extent of reviewing, but as Stephanie said, we are here to talk about anything that you want to talk about beyond the things that we talk about in this workshop. Next slide.
Sure, this is going to be me. I'm going to talk about creating OERs, but I just want to check in really quick. How's everyone doing? Do we want to, or does everyone kind of want to take a quick 5-minute break? Do you want to kind of power through? So if you want, if you can go ahead and, I believe there's a reactions icon at the lower part of the screen in the video. So I believe there's kind of like a little like coffee mug break option. So kind of just want to see how everyone's doing. Because this would be like kind of maybe a good time if we wanted to take a quick like 5-minute break, we could potentially do that. Okay, seeing thumbs up. I'm assuming thumbs up is take a break. Working under that assumption.
Oh, I meant thumbs up was I'm good. Sorry. What do you want it to be, Eric?
Okay, let's thumbs up if you would like to take a break.
But a quick question, how long are we planning to go otherwise?
So this workshop's going to go until noon.
Ooh, okay. I'm going to have to cut out by 11:30. So whatever you do. Okay.
Sounds good. Let's see. I'm seeing a majority right now of just keep on going through. So we're going to go ahead and do that then for now. So let's talk about creating OERs. There's a couple of different methods you can go about doing this. Oops, went too far. So this is a really nice kind of guideline from University of Texas. So it's kind of some checklists of as you're going through the process of making an OER, what are some things to keep in mind? The first thing is design for openness. And that's going to include, do you have permission to publish all of your content? Is all of it available? Are you able to just hang your sources? Are you able to reuse it? If there's things like third-party content, make sure you use like a Creative Commons search, attribute all the content. If you're able to do derivatives, make sure you're following that procedure. And you also want to make sure you choose a license up front. Get an idea of, well, at what point, before you release this information, do you want people to be able to share it? Do you want people to be able to adapt it? Do you want to then be able to make derivatives and share that as well? So kind of think in mind of longevity of the content. Kind of if you were an educator or a researcher trying to access these 5 years from now or being able to adapt them, think in mind of what you'd like to see in a resource. So whenever I create open educational resources for the workshops I make, I always think in mind, what were resources that I wish I had going in graduate school, or resources I wish I had as an educator? And always kind of keep in mind of that. That way it's kind of paying things forward. That's kind of big mentality for me personally. So I'm going to give you a lot of my personal opinions too within this. Again, I just want to mention that this does not reflect the official opinions of CTRL. These are my personal opinions here and there. So I want to make sure I preface that. My big thing is paying it forward and providing open source code, open data, open coding. That's my framework. And the thing too is like, how are you going to be sharing these resources? Ideally, if you're doing anything with Creative Commons, it should be publicly available. If they have to sign in to be able to access it, well, there's a disconnect then. because it's no longer really, it defeats the idea of the ideal part of an open access resource if they have to sign in or they only access by some individuals. And there's some actually ways you can make this public facing. There's things like EdSpace Spaces at AU. You can also do things like there's an OER repository. Now, Stephanie mentioned there's Merlot in OER Commons, and you can actually host those there. That's a good option. And I'm also going to show you some ways you can actually host it other methodologies, such as using GitHub or creating both static and dynamic websites too. So there's a lot of different things you can do with this. And it really helps others learn, especially with coding for statistics, programming, computer sciences. By making these available to everyone, it really makes it and be able to kind of push the science forward. So one example we have, this is actually from CTRL's teaching portfolios. This was actually developed by Kim, Kehoe, and Aaron. So this is on our webpage, and it's a really good resource about how to go ahead and create your own teaching portfolio. I do want to point out a couple of things. So it has all the information needed. There's additional resources. There's the references where the information is being extracted from originally. And we have the Creative Commons license here and how to cite them for the attributes. Another example, unfortunately, so full disclosure, this is where I used to work, University of North Texas. I was in a similar role as a research consultant. And each month I would do an online public-facing research tip. It'd be really short, a couple of paragraphs, a couple of bullet points on a debate in statistics, whether it's like dichotomizing a continuous variable, determining enough power, missing data, so forth. And each of these would be really quick highlights of current areas within the literature, the pros and cons. It'd all be Creative Commons. And it would also link to specific resources that were available as well. Unfortunately, this website, the lab I used to work for this, ended up being rebranded. So the website isn't available right now. There is a trick though, you can actually do something called a Wayback Machine. If you've ever used Wayback Machine for an internet source, it's fantastic. It allows you to actually backtrack and get websites that are no longer in existence and actually get the information back temporarily. So it's a nice little trick. Also, I'm happy to share any of this information, like the research tips, so forth. Again, open coding, open sharing of information. One thing we do now, also mention a little bit about workshop materials. So for the research side of CTRL, we do a number of introductory workshops as well as in-class tutorials. And whenever possible, we try to use public-facing or heuristic data. We also create code. So all the code, the data, the walkthrough handouts, they're available to anyone, whether it's at AU, outside of AU. If someone emails me for it, no problems, they can go ahead and have copies of it. We use currently a tiny URL in a Google Drive for distribution. That way, in case we need to make updates, it's kind of a quick way to share this. However, we are going to be potentially hosting this more publicly, so maybe on a GitHub page. That way we can just increase the public facing of these materials. The big thing for us is we were all there kind of starting to learn how to program, starting to do statistics, and a lot of times coming across that website where everything kind of clicked or made sense of those walkthroughs, those were so incredibly helpful. So it's kind of a way to pay it forward. So we also encourage everyone to adapt the data, adapt the code, try to break it. And that's the best way to learn that, the experiential portions of coding and seeing what works, what doesn't work. So all the materials we have for all the different software workshops we do, they're all under Creative Commons licenses. The CC is at the bottom of each handout. We do this because our belief in open science and open coding, and again, to pay it forward. Here's a screenshot of the R&R Studio. I'm going to mention this in one of the statistical programs that's open source. So we have our learning objectives at the top. We have, every one of these has a specific scenario. That way it's adding an application. It's not just, well, here's how you write this code. Here is some random data, and here's how you run the analysis. Rather give it some context, give it some applied meaning behind this. So these are some good resources that we have available currently. And again, adapt these. If they're helpful for your course, great. If you want to adapt them, more power to you. That's fantastic too. We just do ask that you have the attributes and then also share the Creative Commons on your work too and make it publicly available. That way we're just furthering this trend. I do want to mention too, there is a movement specifically in open source programming towards making electronic copies of textbooks completely free. It used to be specific individuals who were using R or Python or other open source codings. They would go ahead and create an online version of their book. A good example is Hadley Wickham's book, R for Data Science. It is a completely free, completely website-driven version of how to use R from start to finish. It is always going to be free, but you can buy physical copies if you really want to. And it's updated as code gets updated. I have different hyperlinks for all of these. More recently, O'Reilly Publications and CRC Press has been working with authors to allow both the hard copy or physical and ebook versions of the book, as well as have dedicated websites where the entire book is on an HTML page. And it can sort through it as example codes. So there is a large movement towards this. There's also a link here for Bookdown. Let me open this up really quick. So Bookdown is a way to actually write textbooks within the R statistical programming language. It uses and leverages LaTeX as well. And these are all freely online books. So they have geocomputation, actually how to create markdown or book downs or blog downs, how to do text analysis, graphics, statistical inference. This is an entire book made in Bookdown of how to use Bookdown. So it's a little meta, but it's a great resource. And they have different data examples and so forth. I'm going to talk a little bit more about specific tools and data and methodologies shortly. But I do want to mention that, especially with more advanced analyses, there is a trend to making those methods, those analytical techniques, openly available. So a good example, because I remember hearing a little bit about for different methodologies, some more advanced or outside those intro level books, what's available. I can talk mostly about the quantitative methodology. That's my focus within CTRL, quantitative and computational. A really good book that's a blend of statistics and machine learning is actually an introduction to statistical learning. This is a freely available book. It has a great number of different analytical approaches that walks through the theoretics as well as the applications of these. They have example data sets, example figures, example code for labs. It's the whole package, which is really nice. And they update it continuously. This is, I believe, on the 7th edition of the book. So anyone can go ahead and download this and use it in their class. And it really covers a lot of techniques. It's about, I want to say, 1,000-page ebook. You don't have to use all of it, but it is really, really well done. The same authors have one that's Elements of Statistical Learning, which is more for data mining and prediction. Again, always freely available, and they have the example data sets, functions, an actual short course that they use, and information for instructors too. So there's this movement of making this all publicly available. So why reinvent the wheel, so to speak? You can always adapt things too. This is a nice one. This is actually going to be from a dynamic page, which I'll talk about in a little bit. If you're doing more for text mining approaches within R, they have dedicated books on specific subjects. This is a free one from O'Reilly that entirely just covers how to do text mining analysis from start to finish. This is one that's really close to my heart, is Bayesian data analysis. It is by Andrew Gelman and colleagues. This is the 4th edition. And they actually created course material for this entire book. This is the 3rd edition of the book. So they actually worked with the publisher, were able to get a PDF copy for non-commercial purposes. They can download it. They made all of their materials for their course Creative Commons. So it has a whole lot of information. It has example data sets, the code, the book, their materials for when they teach this. It's a fantastic package. You can download the whole thing from Git or just download the whole zip file there too. It also has the lecture slides too. So it's another phenomenal resource that's a little bit more advanced than the intro. They also have it for both R and Python. These are 2 open source statistical programs, which I'm going to spend a lot more time on in a few minutes. Another thing too is sometimes you're not able to find specific open access textbooks on specific more advanced analyses. For example, confirmatory factor analysis with a different caveat. Rather than individuals, you're actually looking at dyads, or individuals like mother-child or siblings or family. So it's a dyadic nature within this. This is a more advanced analysis. There's a movement specifically within R to host a specific code. So this is actually from Randy Garcia. This is from actually an entire 3-day online course they did on dyadic analysis with David Kenny at University of Connecticut, my alma mater. So they actually host all the code, they host the walkthroughs, and kind of all the notes as you run the analysis, what you need to do, what you need to be cognizant of, what it should look like, and what code you can modify. So this is actually all written in R, but then it's saved as an HTML page and posted on GitHub. So another example too is structural equationing modeling, one of my favorites. So you're trying to look at these overarching latent variables that we're not able to actually measure, but we're trying to understand it through observable measures. So this whole tutorial walks through everything from start to finish of how to use a specific software to run structural equationing modeling. This is all using R. The nice thing with the R is every single package. So imagine a package is essentially a bundle of functions that makes data analysis easier. Each one has to include vignettes of how to run the analysis, explanations, example data. That's a requirement for every single package of the over 15,000 packages that are in existence. So there's tons of example data and these heuristic examples too. This is a really detailed one. There's also, I know within American University, there's a lot of researchers who do multi-level modeling. So accounting for nestedness, like students within classrooms or classrooms within schools. Well, if you're doing that type of work, typically you'll be doing a multi-level model. As far as I know, we don't offer a course on multi-level modeling though. So there's a whole bunch of resources on this. This is a really good one too from Penn State. It has example code, it has example walkthroughs of how to run multi-level analysis. But this is my personal favorite. This is University of Bristol, their Center for Multi-Level Modeling. This was actually funded through one of their grants. And their whole thing within the grant was, how can we better teach multi-level modeling? How can we make this available for all the researchers worldwide? So they actually have an online learning module class that's called LEMA, Learning Environment for Multi-Level Methodologies and Applications. It's completely free to enroll, and they walk you, it's an entire online learning class that's asynchronous. I think it takes somewhere between 60 to 80 hours to complete, but they give you all the code, all the walkthroughs, there's video tutorials, quizzes, a certificate at the end. It's a phenomenal resource, and it's free. I mean, for me, being free, that's a big thing. And I'll mention that a little bit later too. Dynamic web pages. So before I talked about actually, you know what? Let me make this a little bit more salient. When I'm talking about static web pages, this is the dyadic CFA one I had mentioned. So this is hosted right now on someone's GitHub page, but it has all of the potential software code. It has all the comments that walks you through the process and walks you through step by step what you should be doing and why, as well as all the specific output and how to interpret it. There's other options too. There's UCLA's IDRA system that has it for Stata, SPSS, M+, and R in SAS. And they have these heuristic ones too, where they provide the example code, they provide how to interpret the results, and so forth. But the nice feature too is, well, static websites are great. You can give the information, but it doesn't allow the students to kind of play around with it. You can also do what's called a dynamic web page, which lets the students actually hands-on adapt the analyses and create visualizations. So imagine being able to, rather than using any code, you can have students kind of plug in some numbers, change the criteria, and then it will actually update the analysis, update the output, and create the visualization. Primarily, this is done either through R Shiny or Python's Flask. So these are kind of two different methodologies or two different programs that can be used in order to create these dynamic web pages. So let me go ahead and pull up an example. Let me go ahead and refresh this. So this is actually using an application for statistics and machine learning. And let's say that we wanted to teach the class central limit theorem. As we sample and have the sample from a larger and larger set of groups, we're able to get closer and closer. The means will end up being more of a central or a normal curve, essentially. So I can go ahead and let's say one of my students go ahead and pick a normal curve or a normal distribution. And let's say we wanted to have a mean of 100 and a standard deviation of 15. Sample size, let's do a sample size of 10. And let's say I wanted 10 samples. You can actually create these interactive websites and see, okay, what does this look like? Does this look like a normal curve? Well, no, because we have so few samples. Well, let's say I did 1,000 samples. That looks a little bit closer. So really it helps them kind of, you can actually use these and leverage these to test different statistical assumptions and really help the students understand the underlying logic of why we're doing certain things. In terms of, before we start talking specifically about resources, like statistical software, I want to mention a couple of things too, because there were some questions previously about more advanced statistical analyses. So there's those online tutorials. There's also some things too you can do too. Like I actually like using Frontiers in Psychology. They actually have every now and then, they have some really fantastic heuristic articles that walk through the theoretics and applications of how to run specific analytical techniques for quantitative methods. So these are really great, and they're all open. Frontiers in Psychology is an open access journal. So this is a really good resource. There's also some lesser known open access resources too. This is general linear model. It used to be called multiple linear regression, the GLM. It's part of AERA. It's a special research interest group, and they have all of their previous articles archived. And they do a really nice job of, I'm kind of randomly picking one and hoping that there's here we go, looking at commonality analysis, or looking at different types of analytical techniques. So every article, or usually with every couple of articles within this series, will be actually a heuristic article on how to run analysis from start to finish, as well as the best practices of how to report them and how to run them. And then this is a new resource I'm obsessed with. So for those who follow me on Twitter at Existential Dent, my apologies. I retweet these folks all the time. It is Gregory Hancock over at University of Maryland and Patrick Curran over at, Chapel Hill. They are fantastic. It's a methodological podcast, and it's actually really quite humorous, but they talk a lot about different trends and methodologies, how they go through different analytical techniques. It's really from an educational psychology and psychological background, but it's really, really nice discussion points too. So it's a really nice way to kind of a different way of approaching statistics and talking about it too. So with that said, again, my big thing is resources. So if you're interested in creating a static website, like a tutorial, let's say you have an example data set and you want to have your students walk through and how to run a specific analysis and how to interpret it. You can actually create a static website. And there's a book down and blog down. So I included the links of how to do these. And they walk you through from start to finish, from really simple examples to really complicated examples of creating these pages, as well as how to create dynamic web pages, how to create a Shiny app or a Flask app. They can actually do a simulation that's hands-on and web ported too. So we're going to shift gears now. Actually, before I move on, any questions about creating an open educational resource? Or anything about methodologies or statistics? Okay, so let's go ahead and move right into open source statistical software. So I want to give you kind of a highlights and the pros and cons of each of the major ones. But first I want to preface of why open source statistical software. And again, I'm going to be mentioning my personal opinions, and those are not the opinions of CTRL more broadly. But with open source statistical programming, a big thing within statistics, especially when you're trying to use programs, is they can be very, very expensive. So commercial programs tend to run a couple hundred to much, much more, depending if you're using an annual license versus a perpetual license. Some of the perpetual license that you can use like for SAS or M+ could run about $1,000. And that's just for a single license. So you also have to think too, let's say that we're using some of these resources, especially for statistics, for software, what's available? Are these available for all students to be able to download the personal computers? Do they have to log into an online system like AU Apps? Do they have to buy their own license of this? While there are versions of the statistical programs that are set up for students, sometimes they limit the amount of variables they can run, as well as the number of cases within the analysis that it can handle. Sometimes it doesn't give you all the features. Now, there's also things too. So it could be an access during the school year. How are they accessing this? It could also be the idea too of, well, once they leave AU, we've given them these skill sets to being able to run all these advanced analyses within SAS, within Stata, within SPSS, which is great. That's fantastic. But once they leave, how are they going to be able to access that software? How can they continue to refine their skills and build on them and make sure their skills don't deteriorate? Because those skills are like a muscle. You have to practice them. That's going to be a big issue too. So we really need, if we were training individuals to use really advanced statistics, that's going to create a problem later on too, because now they can't access the tools they need. There's also marketability. So Oscar, Lechner, and Lee in 2015 noted that there's actually a discrepancy between what programs are used and taught by university, those taught by employers. So a lot of employers, especially nowadays within data science, they're looking for, there are sometimes Stata, sometimes SAS, but a lot of it's going to be R and Python, or other analyses like using Spark or using Java or C++. So my mentality is kind of, this quote sums it up a lot for me.
Eric?
Yep.
Sorry for interrupting, but I can't see any slides.
Oh, is it not? Oh, my apologies. Are you able to, is it visible now?
Yes.
How
you.
did it show the previous ones or no?
Not for.
Like, how far did we get?
I think you only had 2 slides that you went through, so
Yeah.
This one we saw.
Oh, you saw those ones. Okay. So it must have been maybe after I showed up the simulation.
After that.
Yeah.
Oh,
Yes.
this one, yeah, after that. Thanks.
Okay. So
Yeah.
my apologies. So here's the about with marketability. This is actually the citation for the journal as well. And then this is the quote I was mentioning. There is also a general trend, specifically towards SPSS. This is usership for Google Trends and citations of individuals who are citing their use of specific statistical software. SPSS is on a rapid decline. So I do want to point that out. So let's talk about some open source languages. One you might hear a lot of is Python. Now, Python is a general purpose language that is fantastic. It can do a lot. It can do things with APIs. It can do things with extracting data. It can build websites. It can scrape websites. It can create visualizations. It can also do a lot with data analyses too. So things like machine learning, TensorFlow, deep learning, neural nets, computer vision, be able to do image recognition and handwriting classifications. Python can really do this quite well. And it is completely free. So actually, what I think it was Google developed TensorFlow, which is also publicly available. And they just released TensorFlow 2 about 8 months ago. So a lot of the deep learning, image recognitions, being able to have a computer classify what's going on in an image, or being able to classify image recognition, that's all done open access. You can also do things like natural language processing, sentiment analysis, thematic, or actually topic modeling. So those are all things that can be done within Python. It can handle multiple types of data, whether it's text, numerical, visual. It can also handle things like having multiple data sets at the same time. The downside, though, is it's a coding-based language, so it's really not meant to be a point and click like an SPSS. So you do have to learn coding for this, but the coding isn't too bad. It's what's called an object-oriented language, so every object is a thing. It could be a data set, it could be a list, it could be a specific value. It is what you make of it. My personal preferences are, that's what I was trained on. It is extremely versatile. It started off as a statistical program, and it actually became more of a general purpose program now too. It is community driven. It is also, of the programs, it is one of the most inclusive community. A lot of that is because of the group We Are Our Ladies, which is a fantastic organization. Every week, it's a new woman within data science field, whether it's applied, academic, and so forth, and they spend a week tweeting and giving examples of how to run different analyses, how to do some coding, to more broadly things like interview questions for data science jobs, troubleshooting. It is a really inclusive community. And they host all of their code on their GitHub page. The nice thing with R is there's over 15,000 packages, which allows you to run specific types of analyses, use specific types of data. If you imagine a certain type of instance where you want to run a certain type of analysis or work with a type of data, there's probably an R package to do it. If not, you can actually create your own, which is really nice. It has the same functionality as Python. You can actually have R and Python talk to one another. You can actually run Python code within R, and that's not a problem. You can also create interactive websites like that central theorem one I showed you all. You can do it that way. You can also create what's like formatted data reports. So frequencies, descriptives, analytical reports to like into books, into PDFs, into HTML sites. It's fantastic. And actually there's an increase of R being taught at AU at both the graduate and the undergraduate level. I know there's some classes over at SPA, SIS that are teaching with R currently too, as well as math stats. I believe their data science program focuses a lot on R. And actually in terms of image recognition, that screenshot in the lower corner, this is actually taking classification images of specific types of clothing and seeing how well the algorithm can correctly identify what the item is. Did pretty good except for not so well with coats and hoodies. It's not that great within that. Another option is Julia. Julia is a newer option. It is designed specifically for high performance. So it's a dynamic language like R and Python. However, it runs as fast as C. So if there's anyone who does any programming within C, it's incredibly fast, and it's designed to be implemented into what's called multi-threading. So rather than having it only be able to run one code at a time, you can split your code up and it'll run all of them simultaneously. It's provided under the MIT license, and the source code is freely available on GitHub, so you can actually modify it too. And there's numerous resources on learning Julia. So far, all the ones I've talked about, Python, R, and Julia, they actually have Twitter handles too, so you can actually tweet users with questions and they'll respond to you. It's a really active community. There's also Octave. If you're familiar with MATLAB, this is an open source version of MATLAB. It's all community developed. And you can actually run some MATLAB scripts in Octave, but you might need to make some edits because of some different coding, because MathWorks, MATLAB is commercial. So it's a different way of doing this. Those are all command line or programming line commands that you'd have to type out for this, syntax-based languages. The next two I want to show are actually point and click options. So they're going to be more similar to SPSS. This is called Just Another Statistical Program, or JASP. So JASP is an SPSS like R interface. They call it SPSS lightweight, essentially. It is point and click, just like SPSS. It is and will always be freely available. Its output is actually an APA format. So unlike SPSS, where you have to copy it into Excel, into Word, redo all of it, put in an APA format, redo all the figures, you don't have to do that within JASP. It does it for you. And it contains a majority of undergraduate research methods we'll need. So like if you're using ANOVAs, t-tests, regression, chi-squared, factor analysis, descriptives, it has all of those built into it. It also has a null hypothesis statistical testing and Bayesian statistics too, as a default. If you're doing Bayesian though, especially if you're doing that within class, I recommend R instead. It gives you a little more flexibility, but this is a really nice primer. I used to love JASP. I actually have a friend who, at their university, they couldn't afford a commercial version of license of SPSS anymore. They moved over to JASP and they have loved it since. Jamovi is a new one.
Eric,
Yes.
are you aware of anybody using JASP at AU? Because, yeah, I think it's a potential.
I currently do not know of anyone specifically using JASP at this time.
Okay.
I'm happy to talk more about it though. It's a good system. I'm actually more partial to Jamovi now. Jamovi is another option. It's similar to JASP. It does have Bayesian and non-Bayesian. It's designed to look like a spreadsheet though, and it provides APA formatted output. But the nice thing is if you're familiar with R, you can actually create R code, have it create macros and give you additional flexibility. So it actually has an R integration, and they also promise it will always be free.
Okay, thanks.
So kind of shift gears a little bit. I want to talk briefly about GitHub. Out of curiosity, a quick show of hands, is anyone familiar with GitHub or use GitHub? I see a couple of head nods. So it's meant for version control, particularly for code and for data. So it's used by developers to debug code, to post it, to report issues, and troubleshoot and provide fixes. You can also use it for data projects. You can kind of treat it as almost a repository at times. But the nice thing too is actually users are more and more using these days for like creating schedules for different like workshops or different conferences and hosting everything on those websites. So in one of them is the dyadic data analysis workshop for 2018. They have all the code, all the data, even the schedule posted there. It's Randy Garcia's site. And then the right-hand side is my personal one, where I actually have my simulation studies, my code, my data, just to make sure that's all publicly available. I also want to be really conscious of time, so I'm going to go through the couple of codes, or a couple more slides, and then we have another activity. So if you're interested or using R or RStudio or any other language, this is some example language I use in my syllabus, specifically for R and RStudio. So I provide the specific links where they can find the materials. If you want any of the course material that I have or the syllabus that I have, I'm always happy to share those. This course was developed in mind for Monte Carlo statistical simulations. So it is kind of, my big framework within this is teaching R. I want them to kind of explore in that kind of the mother of invention framework, that kind of trial and error, see what works. There's 100 ways to make your code work and see what works best for you. So I have always a note in my syllabus that they can always adapt and kind of see what works and just use trial and error. So I typically do like an exercise. So kind of give them an idea of like kind of where I want them to learn about statistical probability, specifically dice rolls and coin flips. So actually kind of showing them how to create, I give them a template boilerplate code, and then they need to kind of trial and error adapt it to make it kind of fit this different scenarios. So it really kind of focuses them on taking these scenarios, creating code to then have actionable outcomes with it. And this is all situated within my learning objectives. This is actually a screenshot of the simulation exercise 1. So kind of uploading the document as a PDF, they have to say, like, using a fair coin, flipping it 5 times to determine who pays the bill for dinner. Is it them or their friend? And showing me the output from that. Let's say that someone has penchant for odds being in their favor, so it's no longer a fair coin, how you would do that. And so that way they can kind of see how to adapt the code. So when I teach this, I have all the information. I have a boilerplate code in there. I have examples that redirect them to the supplemental textbook or online resources where you can kind of get further information. Especially the specific learning outcomes that I'd expect them to learn from completing this exercise, as well as example code and a video walkthrough that kind of walks them through the general code or the template that I'm asking them to use and then adapt. Erin, do you want to talk about learning objectives or learning outcomes?
Do I ever? So of course we have learning outcomes on a CTRL workshop, but I'm thinking in the interest of time, we're at 11:50, we want folks to be able to leave at 12 without missing anything. So Eric and Stephanie, what are your thoughts? Should we move into the Q&A portion? Would that be okay?
Sure.
Yeah.
Okay, just
Yeah.
knowing that it's 12, and I think given all of the interest and the resources that we are talking about on campus, this is just the beginning of a huge conversation. And we want to continue having these conversations with you. So yeah, so we have about 9 minutes left. So are there any questions? Feel free to type in the chat or raise your hand. We can unmute ourselves unless it gets kind of too wild. We only have about 10 people kind of hanging out still. So go ahead and unmute yourself if you have a question, please.
Hey everyone, this is Paula. I had a quick question, actually, just soliciting people's opinions about this. But I wondered when we start getting into using like some of the courseware options that were reviewed today from like MIT, or I know I was reading different news articles about how like Coursera, because of the pandemic crisis, started working with tons of universities, you know, across the world really, to kind of jump in, so to speak, to try and help and make courses available for students at universities and help universities kind of continue the learning for students. And I don't know, if it were me and I were a student and I start seeing like a lot of resources from another university or from Coursera that I know I can basically go get for free for myself, it's like, why am I then paying this American university tuition? And I kind of think of these things also in the context of like the class action lawsuit, I guess, that's been launched against AU recently from students who feel like online learning is not equivalent to in-person and they want tuition reductions and all of that. And I'm just wondering in the context of how we use resources, if anyone just has any thoughts or guidance about that.
I have some initial thoughts, but I'll open it up if others want to talk first. So my first initial thought, this is a really great question and point, and something that's always probably on a lot of our minds. And a lot of the studies that we see on online learning is that they are as rigorous and as useful, and you get the learning outcomes that you do for in-person classes. And the one thing that makes an online learning experience useful is having that expert facilitator there. And so there are other resources, and depending on what the students are looking for, maybe some of those might be what they're looking for, but at AU, it's the access to you. And so using all of these to kind of supplement your teaching or kind of guide your teaching, you know, looking to the modules as kind of just a guide rather than, of course, not like putting it onto your Blackboard site or anything like that, which I don't think that you were proposing at all, Paula. But I think that's important to be mindful of and to use these as kind of tools and resources, but these are not an alternative. And at the end of the day, what they need is you and the discussion boards, and they need your expertise. So that's kind of my first thoughts. Any others?
Thanks, that's really helpful.
Any other questions?
Hi, this is Hannah. I'm just thinking of ways that we can incentivize, faculty to do this. It's so much work to rethink your syllabus and your curriculum. So what would incentivize faculty to do this?
I don't know, this is Paula. I think for me as a term faculty member here, I've always felt a little concerned, and I think things are getting much better on campus right now. And the Faculty Senate has done some things in this area to make sure that merit, promotion reviews, all of those types of things, contract renewals, are really kind of including more robust measures about going beyond SETs. And I know there's more flexibility now for us to kind of demonstrate how we go beyond. And it would be nice if there was some, I don't know, special kind of recognition or kind of push where, you know, faculty could kind of use this as a measurement in that way of one of the ways that it means to kind of go beyond SATs in your teaching.
I love the idea of being able to kind of get recognition for this, not just to be recognized because it's great work, but for tenure and promotion purposes. And so we recently had Scholarship of Teaching and Learning work. I can't remember what the phrasing is. Jesse, maybe you remember. But it is kind of one of those credentials that you can use towards tenure and promotion right now. And so that's maybe OER could be kind of the next thing that we can kind of continue to recognize. We're also doing a lot of teaching portfolio work right now to give ideas about how to compile and create your own teaching portfolios to showcase these kind of beyond SETs measures of your teaching. So that's another way that we would kind of recommend offhand. But I love the idea of getting credit for this in other ways, whether that's awards and grants or officially written as guidelines for tenure and promotion.
I think, this is Jessie, I think that there could be some incentive for departments to be on, you know, it could come from the department level and not necessarily monetarily, but it really will benefit some of the courses to be, to have more, for the students to have more access. And like you mentioned early on, Erin, about the, you know, having, oh, sorry, my video's off, but having, increasing retention, and that could just be for retention for majors too, and them not switching majors. So it's, I think that it's not just at the university level that it could be a benefit, but also at the department level or the college level, the school level.
Yeah, the research, and especially using the COO framework and costs, not just for students, but what do all these outcomes really mean for us as a university, and continuing to produce that research and showing it to, you know, and stakeholders and department heads. That's a really, really great point too. Yeah. All right. Thanks all. Thanks all for sticking with us till the very end. You know, this was a lot of content, but I'll leave it to Eric to close out. Thanks, Eric.
Thank you so much for all attending. We're going to try to get these slides to you all, and if you have any questions about any of the materials, just let us know. Happy to be of help.
Thanks everyone for being here. Really appreciate it.
Thank you. I just had a quick request. Could these resources also be made publicly available through CTRL to everyone? Because I feel like it could benefit everyone who didn't even attend this workshop also.
Yeah, Hannah, that is a really great idea. I think what we will do is, excuse me, we'll send these resources directly to everyone that attended so you get it right away. And then we will make these resources available on that May faculty workshop website. And that'll stay up all year round, so anybody can access that.
You know, if you wouldn't mind, we might be able to put that up on a library page also that would be a little bit more permanent. So yeah, I'm happy to, I know we have some linked, but I think you may have some that we don't, so.
Great. Yeah, okay, Gwendolyn, that sounds good. I'll touch base with you after this.
Great,
awesome. Thank you all so much.
Thank you.
Yeah, this is great, thank you.
All right, everybody, have a good rest of your day.
You too, Lindsay. Thanks.
Thank you. Bye-bye.
Thank you. Bye.
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 Oh, are we still recording?
Still recording. I'm gonna